EME2 in Australia. Now we have quite an international audience joining us today, so we'll just run through a little bit of detail about what today's webinar is about while a few latecomers join us. Our group are very keen to present today's webinar on Orbi Module LV Class 2 or EME2 for those of us who struggle with our French, and I would like to introduce our team. It's Dr. Laszlo Petho and Dr. Eric Denneman. Both of our doctors are based in the sunny part of Australia, which is Brisbane, and have had key involvement in the implementation of EME2 in Australia. There's a picture of Dr. Laszlo Petho on your screen now, and he's a principal engineer with ARB Group. He is a civil engineer and has a PhD in pavement design and asphalt technology. Hello, Laszlo.
Hello, Kathy. You said it right, that's the sunny part of the country.
Fantastic.
So,
and are you experiencing some...
today here?
Great. And joining you in your Brisbane office as well is Dr. Eric Denneman. Eric has worked in many parts of the world, including the Netherlands, South Africa, the USA, and has now settled in Australia. He also holds a PhD in engineering. Hello, Eric.
Good afternoon, Kathy, and good afternoon to everyone.
Fantastic. So our two doctors will share the story so far on implementing EME2 in Australia and where to next. My name is Kathy Decoris and I'll be moderating today's webinar. Any questions or comments that you have will come direct to me, so please don't hesitate to send them through along the session. Some of the housekeeping items for the webinar is we have a questions box where you can type your questions or comments, and just as a practice I might ask everyone now to let us know in just a few words if you can type in what you're hoping to learn about from today's webinar into the questions box. The next slide will show us that today's webinar will run for approximately an hour. We have around about 40 minutes of presentation time and 20 minutes of question time, so please send your questions through along the way. We will send you a recording as well as a copy of the presentation via email after the webinar today. So we've got some responses coming through. Thank you, Ian, who is wanting to know what the latest developments are in Australia. Klaus is wanting to know just what it is. Nizam is wanting to learn about the advantages, and Andrew wants to know what all the fuss is about. So thank you very much to those of you who have jotted in what you're wanting to learn. Please keep the comments and questions coming, but I'll now hand over to you, Eric, who'll start us off.
Yes, thank you, Kathy, and thank you for the introduction, and we'll actually get to the question by Nizam almost immediately. So as Kathy tried to introduce, and I will now make another attempt at abusing the French language, this presentation is about Enrobé à module élevé, or simply in English, high modulus asphalt. We will start with a brief background to EME2, and then we'll be talking about performance-based mix design of EME, because the way EME is designed is very different from conventional asphalt mix design in Australia, which typically uses a volumetric mix design method. Then we'll move on to the tentative Australian EME specification limits. So in this study we've developed specification limits for mix design using Australian test methods. Maybe tentative is the wrong word. It should probably be interim specifications, because we're building quite some confidence with these new specifications. Then EME2 pavement design within the Austroads guide. So we've looked at how to use EME2 within the framework of the normal pavement design guide in Australia, and we'll be talking about that. And then finally we'll be talking about the EME2 demonstration trials that have been installed to date. Okay, so then to Nizam's question, why would I be using EME2? Well, EME2 has got some quite unique properties when compared to conventional asphalt mixes. It's very workable due to the high binder content, but the end product is very stiff, hence the name, high modulus asphalt. Rust resistant, it's fatigue resistant due to the high binder content, and finally it's moisture resistant. And this is thanks to the high binder content. We're using about 6% binder by mass of aggregate, and that is of a hard binder. It's a new binder type for Australia. It's with a penetration value, so it's a European specification, a pen value of between 10 and 25. It's compacted to a low air voids content, at least below 6%, but we aim for about 4% construction voids. And most importantly of all, it's strictly a performance-based design method, and that's what sets it apart from conventional asphalt mixes in Australia, is that we design it to be workable, stiff, rut resistant, fatigue resistant, and moisture resistant. And that's what we'll discuss in this presentation. And then the second part of the answer to the question is why we'll be using EME2 is because it basically leads to thinner pavements. So this is a snapshot from the French catalog design guide, and here they're comparing pavement structures with their conventional GB3 asphalt materials versus an EME2 structure, and you'll see that on average it leads to about 25% design thickness reduction, and we've shown similar results for Australian pavement designs. Laszlo?
Okay. Eric mentioned the very high binder content, which is about 6%. On the top of this slide, you can see a normal DG20 HM mix, which is a heavy-duty dense graded asphalt in Queensland, a typical one. Binder content is roughly around 4% of the mix by weight, and that would be around 5, 7, 6 roughly for the EME2. If you convert that into the volumetrics, you can see on the second columns of each chart that the binder volume is quite high for the EME. And Eric mentioned a 6% air void for the EME. This is what we target. But what we target, that's the maximum. So we would like to see rather lower air voids with the EME. How do we specify EME2? That is relatively simple. This is a snapshot out of the French specification for asphalt, for dense graded asphalt. And if you go to the highlighted row, that gives you all the specification requirements which you have to meet for an EME2 14 mil aggregate size. That specifies you the volumetrics in the workability, the moisture sensitivity, wheel tracking, stiffness, and fatigue. So it's really quite simple if you put it that way, but we are going to give you more details about the difficulties how to come up with an EME design. And you may wonder about why do we call it EME2, because that's class 2. The class 1, highlighted in blue on this chart, is EME1. It's not really used in France, but the difference is in the fatigue performance. That's only one single number, 130 microstrain for the class 2 EME and 100 microstrain for the class 1 EME, but that little number makes the performance very different. Audit presentation and audit work relates to EME2, so we are not going to refer to EME1, even if we just leave out the post-nominal 2. So EME always refers to EME2.
In Australia.
In Australia, sorry. That's correct. That table gives you a summary of what test methods is being used in France when you test and specify EME. That goes from level 0 to level 4, where you specify, where you test the volumetrics and go through the workability, moisture sensitivity, wear tracking, stiffness, and fatigue. In the Australian context, the level rather relates to a step, because on this chart you can see the updated design flow chart for asphalt in Australia. That's from AGPT Part 4B asphalt, and in Australia we specify level 1 and level 2, but within level 2 you can discover all these test methods which I just described for EME2 testing, which is the moisture sensitivity, wear tracking, deformation resistance, stiffness, and fatigue. The beauty of this project is that we do have all the test methods in Australia, which needs to be performed for designing an EME2, but unfortunately there are little differences in between the European and the Australian test methods, and you cannot directly use the Australian test methods to design an EME2. So this is why during the project we had to make some slight modifications to some of the test methods, and that was we did it with the knowledge and with the support back from industry that any changes or any modification in the parameters is supported up until there is a clear technical reason for that, and that is all explained in the recent EME2 report, which is available on the Off-Roads website. Just give you an example for the wheel tracker or the wheel tracking. In France, they use the large wheel tracker, 60 degree, 30,000 cycles, while in Australia, all the laboratories are equipped with a small wheel tracker. We do the test at 60 degree, but we run it only to 5,000 cycles, which is 10,000 passes. So that is really a big difference, and you can see the pictures of these different equipment. The same happens to the stiffness and the fatigue. In France, the trapezoidal 2-point bending test is used for the stiffness and fatigue, and in Australia we use the 4-point bending test method, and there are also differences in the strain levels and the temperature and the hertz.
Okay, so this slide tries to explain the process that we went to in developing Australian specification limits for these different performance parameters using the test method that Laszlo has just explained. What we did was we used an existing EME2 mix design from France with a proven performance, and that was, therefore we knew what the performance of this mix was in the different French test methods, and then in Australia we tested the same mix using Australian test methods for the similar performance parameters, and that was basically the benchmark from which we departed on comparing the French specifications to relevant Australian specifications. This was also supported by industry, who went through the same process, so they sent materials to France for mix designs to be done. We then said, well, we had comparative results from France and from Australia, and based on that we went about setting specifications for the different Australian test methods. Multiple mixes were tested, and that process is still ongoing. Some of the Australian standard and Off-Roads guides to pavement technology test methods were slightly modified, as Laszlo just alluded to, and the details on that are in the Off-Roads report on this project. So these are the tentative specifications or interim specifications. that we got to for EME2 mix designs using Australian methods. So through the process from the last slide, we developed the following specifications. So in terms of workability, that is air voids in specimens compacted by gyratory compactor. We set a maximum value of 6%. Water sensitivity, we used a modified Lotman, where in France they used the Duryea test. A minimum retained tensile strength ratio of 80%. Wheel tracking at 60 degrees C and 30,000 cycles. Again, that's slightly different from the current conventional method in Australia, more cycles. A maximum rut depth of 6 millimeters in ATPT T231. Minimum stiffness modulus. This is high modulus asphalt after all. So there's a requirement for minimum stiffness at 15 degrees and 10 hertz of 14 gigapascals in the flexural bending tests. The flexural bending test has been updated to make this possible. We're now testing a sinusoidal loading mode. And then fatigue resistance, using the same test method at 20 degrees, 10 hertz. And we're testing a minimum of 18 specimens with 6 specimens per strain level to determine a fatigue equation for the material. We have a minimum strain level to 1 million load repetitions of 150 microstrain. And this is again in sinusoidal loading mode. And then finally there's a richness modulus of Leslie will give some more background to that, but that's basically the equivalent of the film thickness test that you may be familiar with.
That's right, and the audience may be wondering why don't we have any grading or air void requirements here, and that's because this is a purely performance-based mix design. So you don't really you are not bound with the grading envelope and air void. There are certain controls around the air void, but these are not the main driver of the design. You need to still start with the conventional asphalt design. So we talked about how you specify EME2. We are going to talk about a little bit how do we make an EME2 design. In the French guidelines you can find some guidance or control points for the grading, but these are not specification requirements. It's just a good starting point that gives you a good understanding what you can get out of the mix. In Australia, we specify EME2 as an EME2 14 mil mix, where you have the maximum aggregate size at 19 millimeter, and there aren't any specification requirements for the aggregate grading.
Sorry, Laszlo,
for the mix. Yes.
Before you continue, can you let us know where you would use this mix in the pavement structure, and also what the thickness of the layer would be that you typically construct with?
Yes, sure.
14.
So this is a structural layer. It's not a wearing course. You can use it as a structural layer, or in certain cases as an intermediate layer. And what was the other question?
What the layer thickness would be?
The layer thickness is between 70 millimeter and 130 millimeter for a 14 mil aggregate size.
Yes, because that's also different than people would probably be used to. But that's
yes,
typical
that's
for
right.
an EME. Yes.
With the binder content, as Eric already mentioned, you don't need to meet a minimum binder by mass requirement, but you need to meet a minimum requirement for a binder film index, which is called the K value in the French specification. This equation was modified to include the binder content as we specified in Australia, which is the binder content by the mass of the total asphalt mix. You can also see that that includes the surface area and some correction for the particle density. For an EME2, you have to meet a minimum 3.4 K value. All the details are described in the Oxford's report. I'm not going to talk about that right now, but I give you an example for the previous grading. For that grading, having an aggregate density 2.65, you would have a minimum of 5.3% binder by the total mix if you want to meet the minimum K value of 3.4. And I need to mention that even though the air void content, the VME, the VFB are not specification requirements, the designer still uses it to come up with a reasonable mix. So that's the starting point. But the big difference is that this is not a specification requirement. The specification requirements are what Eric has just listed on the table. That's the workability, moisture sensitivity, wear tracking, stiffness, and fatigue. It's a very important component of the EME2 mix design, how you compact your laboratory samples. In Australia, we can use the automated Mercer compaction, and for gyratory compaction, we have two different equipments. That's the gyropack and the servopack. But for EME2 design, it's only the servopack can be used. And the reason is because the vertical loading stress and the gyratory angle, the rate of the gyration, is different to those parameters which is described in the relevant Osterode standard. And the reason why we specify this and alter or make it different to the relevant Osterode specification, because these parameters are used in France, and this compaction in the lab is related and validated against field compaction of the mix. So it's very important that already in the design phase you collect information about the workability of your mix and how it would perform in place when you try to pave it.
Yeah, so this is very different from what people may be used to in conventional mix design. You would target a minimum and a maximum air void content. In terms of the EME, we only have a maximum air void content because you want the mix to be workable.
That's right. And in situ, basically, you can reach quite close to zero air void content, but this is where the performance parameters step in, because you can make your mix close to zero, but in that case, your mix may be unstable and fail during the wear tracking test. So that's not an easy game. It's quite exciting and requires a lot of experience. In terms of workability, already mentioned that we have to meet a maximum 6% air void at 100 cycles. On this chart, you see three different EME2 mix designs, and they are very different in terms of workability. Your mix number 3 would be quite risky in terms of workability. You may need to consider extra caution on site just to make it right in the compaction. But number 1 and number 2, they are around the 3% air void mark, so they are considered as a workable mix. A wear tracking test, from the shape of the specimen, you can see we are using the small wear tracker in Australia, and like I mentioned earlier, that is a significant change to the current test method. That's 6 times the number of the passes for the EME2 as for any normal testing, which is 10,000 passes currently. So we put the EME2 to a very harsh condition, and we specify a maximum rod depth of 6 millimeter. Flexure modulus, minimum of 14,000 MPa using the 4-point bending, 15 degree and 10 Hertz. And while we are talking about the workability and achieved air void content, you can see on the last column, if you have a very high or relatively high air void content, 5.4%, your stiffness will be significantly lower if you compare this mix to a low air void content, which is on the first column. It's certainly just a snapshot, so you cannot really separate this chart from the other performance parameters. So you have to consider all the performance parameters at the same time. And finally, the fatigue. It's 3 strain level, 18 beams are what we specify for EME2, and the reason is because we would like to have a very stable, a very robust number, and a very reliable testing, and the specification refers to 20-degree testing. But I just wanted to give you an update what we have been doing since the report has been published. We are testing the same mix at different temperatures and move forward into the EME implementation project.
Yes, and maybe people might wonder why 18 beams. Well, that is because typically you would see a lot more scatter than you see in this nicely grouped fatigue results.
And that's right. But just to make sure that we have, and you are absolutely right, Eric, just to make sure that all test results are compatible and reliable, we specify the SN number, which is also in the European test method. So with 0.19, this is a perfect fatigue curve. Okay, why do we do all that difficult work with the fatigue and the stiffness, which is the last phase of the design, the mix design? Because those two parameters go straight into the pavement design, at least in France at the moment. And the benefit of doing so is you can do your design or your pavement design at any temperature which is representative for your local condition, and you can also make improvements to your mix, and that enables innovation, and that calls for a more optimized mix and pavement design together. You certainly have to consider the shear factors and the risk factors in the design, and that's the French methodology. And Eric is going to give us an update on the Australian way.
Yes, so Laszlo just gave an example of how in France the fatigue performance in the laboratory is linked to the prediction of fatigue performance in the field. In Australia, for the moment, we are using the Shell fatigue equation, which is shown on this slide, and also for the work that we've done in implementing EME and pavement design, for instance, for the Queensland Department of Transport. We're using this equation, which is fine for EME, but it does not allow mix-specific fatigue equations to be used for the moment. So currently within Australia, we just design for EME as you would for any other asphalt mix using the Shell fatigue equation. That's for the time being. Yes. Okay, then in terms of the selection of aggregates, this is just a guideline to help people design these mixes. So we don't use natural sand, only crushed aggregates, relatively high quality aggregates. We're using no hydrated lime in the mix. Aggregate and filler selection should consider workability of the mix. And currently we're not using a wrap or warm mix asphalt, so you will not see that mentioned in the reports on these trials. However, that is definitely part of the future. There's no reason why you wouldn't use wrap or a warm mix asphalt, or construct EME as a warm mix asphalt, that is. Then these are just an overview of the binder requirements. Again, currently there is no Australian specification for the type of hard binders that we use in EME. which means that we're using the European spec, and what's shown in the screen is the specification for the 1525 binder. You could also use a 1020 type binder. So what is important in this and how is the penetration is between 15 and 25, and then softening point is also important in terms of the European specification. One thing that we need to highlight is that viscosity spec, like we use in Australia, there's just a minimum viscosity in this specification, and that is not the main parameter in which they use to specify binders in Europe. So this minimum value is just that. It's a minimum value. A typical EME or penetration grade binder will have a viscosity that's well north of this 900 Pascal seconds. Okay, then just a quick overview of the national work on EME in Australia. So a couple of years ago we had an exploratory study where we just did some, well, basically showed that you can design EMEs in Australia as part of Austroads. Now that currently there's an Austroads project that's aimed at setting those interim specification limits for Australian EME for mixed design. And also there's a project for the Department of Transport in Queensland which aims at coming up with design methods, well, basically allowing for pavement design using EME. And then industry has played a major part in supporting this. So there's funding from Austroads, there's funding from TMR, and then industry has played a major part in supporting these projects through testing and construction of trial section.
Okay, Kathy, are you still there?
Yeah, can you please check if anyone is awake out there?
Yes, thank you, Laszlo. Everyone is awake and very attentive, judging by the number of questions that are coming through. Ian has confirmed he's awake as well, so thank you. Thank you for that, Ian. Now, we do have some questions. I know some of the questions did come through earlier, so they may have been answered in this first part of your presentation. But if you're okay, we'll go through some of the questions that people have asked at this point.
Yes, sure.
Fantastic. Okay, so
you might want to start with the questions that you asked at the very start, Kathy. Because I don't think we answered those.
Okay, all right. No, yeah, I'm talking about the questions that have come through since then, as you've been speaking. So people have been very attentive, and one of those people is Ryan. And Ryan's question is, what percentage of asphalt pavements in France are EME, or what is the volume of total asphalt volume per annum in France is EME? Not sure if you have an answer for that one.
To our best knowledge, and the thing is you can find mainly publications in French language, which makes it quite difficult, but in English publications there's indication it's on major motorways and airports and port terminals that only EME, which has been used in the last 10 years, and but I cannot really give you a figure or a percentage, but having seen the density of the motorway network in France, that would be a fairly high percentage.
Fantastic. Ryan had a follow-up question asking, again, a percentage one. What percentage of the saving is due to high binder compared to other performance parameters, noting that the use of high binder base course already saves 40 mil of asphalt in Victoria?
It's really very different than a normal high binder course, and that is mainly due to stiffness, not so much the fact that the high binder really only offsets the fatigue performance. The fact that you have a very stiff mix that will normally impact on your fatigue performance, but EME actually has quite a good fatigue performance despite the hard binder. So Basically what that means is that you can get away with a thinner pavement structure and still give the same protection to your underlying layers and your subgrade. So in terms of pavement designs, that's where the main benefit comes from reduced stresses on the underlying layers that you would get through your calculation.
Okay, thank you, Eric. Laszlo, this next one is for you, and it's, is binder absorption of aggregate taken into account for the binder film index?
At the moment, it's not specified, so we've taken 0. But based on ongoing experience, we may need to change that. But remember, in the end, all you need to meet, that's the performance specification. So the performance limit. I don't think any binder absorption would make any big difference on that. But just to make the design right, we may need to consider that in the future.
Okay, thank you. Warren's asking about, are other methods of compaction acceptable for QC, QA purposes once the design has been established?
There, typically you would only check binder content, grading, and density of the asphalt in the field. There's no QA in terms of knocking up Marshall specimens and determining the density. Unless that is really up to the contractor, though, how they want to monitor quality. That's not really part of the specification in any way. So pay factors, for instance, should not be determined based on specimens that are compacted in the laboratory.
Okay, thank you. We'll take a couple more questions. There are quite a few coming through. There's some questions in regards to aggregate, and Rod's asking, what do you mean by high quality aggregates, i.e. what are the requirements?
I think there it would be easiest to just refer to the Astro's report, because we have tables with limits in there. I think it's
That's right, and not only the coarse, but the fine aggregate and the filler. So that's all described there. But
yeah, I don't think you can.
No, that's fair enough. They are some quite detailed questions. We also have a couple of questions asking about field trials, and have there been any field trials? Ashley and Ian are both asking that question. So we might actually
coming up in the second part of the presentation.
Yeah, absolutely. So we might take this opportunity to move on to the next part of the presentation.
All right, thanks, Kathy. And back to Eric again.
Okay, yeah, so something we didn't mention is that before coming to Australia, during my time in South Africa, I was involved in basically transferring the same technology to South Africa, because something else that we didn't mention is that more and more countries are adopting this technology. It's not just Australia who are following the French. So this is just a slide based on a trial that we did in South Africa, and we followed a very similar process in terms of developing specifications for local test methods there. Just to give you an idea, this is where we first placed EME in terms of high demand situations. You see this train of trucks. This is for the Durban Harbour, which is I think the largest harbour in Africa. Estimated traffic 8,000 standard axles per day. And the pavement design was performed by CSR, where I was working at that stage together with industry partners, as well as the mix design. And we had 160 millimeter EME there with an SMA surfacing. It was constructed in 2011, and the reports. Something else to say there is that if you see the traffic there, they were used to often replacing that asphalt there due to rutting, deformation, and all kinds of damage. Since the EME has been installed, the SMA has been suffering, but the EME is performing well. They have some minor rutting, and I also understand that EME is now has been used in trials on some major other projects in South Africa since then. So that's just background on trials elsewhere in the world.
And we already have had a trial here in Queensland, the first one in Australia, and that trial was constructed exactly a year ago. That was placed in Eagle Farm, the Cullen Avenue, and this is actually an access road to an asphalt plant. It's a dead-end road, so we can monitor the traffic very well, and we certainly have very heavy traffic on this 250-meter long road section. And we had many objectives for this trial, because that was the very first in Australia. The three main items to monitor was the construction and production. We had questions before that, do we need a gritting, for example, on the surface of the EME if we want to leave it open for the traffic before the wearing force goes down, or can we meet the production tolerances? Eric mentioned about mentioned the production tolerances. That's the driver, how you monitor the EME. And we also had questions about how many rollers do we need, what type of rollers, what would be the rolling pattern. So that was really an exciting day, and with a lot of preparation work, I'm happy to report that everything went very well. And we constructed a 100-millimeter thick EME base layer with a control section of 150-millimeter DG20HM. On a very short section, we had an EME 150-millimeter thick, and that all was covered with a 30-millimeter thick DG10 asphalt. So that was really a hot day when we placed the trial. Was the high 30s, and you can tell straight away if you pave EME, because the production and paving temperature is definitely higher compared to normal asphalt. So I can tell you that was really hot out there on that day. And but since then, despite of the hot weather in Queensland, this trial has been performing very well, and we have been monitoring that in terms of polling weight deflectometer testing. We also monitored and monitoring the functional performance, which is rotting IRI and surface texture, and we certainly review that in light of the pavement design. But at the moment we haven't seen any failure, not even a single one on this road section. So I'm not sure how long would it take to have it fail, but we will see. So at the moment we know everything about the pavements, and because we implemented with the help of industry a weather station on site, we know everything about the pavement temperatures and the environment, the climate. There are other trials coming up in New South Wales and in Victoria. The Victorian trial, we just had a working group meeting this morning, and it's very promising that it will be coming up very soon. So we would love to see more EME trials in the country.
When you say very soon, what?
Very soon, we are hoping for a couple of months, 2 or 3 months latest. And why was the trial in Queensland so successful? Because we had many parties interested in this project, and every organization and the people behind the organization did a very good job, and not only in the preparation but on site and after construction in terms of monitoring. and the key partners in the Queensland trial were the Bowler Asphalt, the Semi-Bitumen, Brisbane City Council, the Australian Asphalt Pavement Association, Department of Transport and Main Roads, and we had significant input from Colas International technical staff and our own project team from the Brisbane office, and we have been using our Melbourne laboratory extensively on this project. A couple of pictures about the trial. Brisbane City Council was so kind helping us painting the surface for an easy reference. So anytime you go out there, you don't need our guidance. You can pick out which section is the 150 mm thick EME2 and where the control section starts. At the moment, like I said, you cannot really see any difference because everything performs very well.
And for our international audience, they may need some help with the Australian abbreviation. DG stands for dense grade, so DG20 is a 20 mm normal dense graded asphalt with about a 40-50 pen.
That's right. Okay. Basically, the question would be, why do we do all that difficult and detailed work? In the end, because we would like to see EME placed, manufactured and placed, and for manufacturing and placement, you need a specification for mix design, and you need some sort of specification or guideline how you design pavements. In conjunction with transport and main roads in Queensland, a project-specific technical specification, PSTS 107, has been drafted and consulted by industry, and the same happened to the pavement design. The pavement design supplement that has been also consulted, and both documents are in the approval process. At the moment it hasn't been approved, but it's in the pipeline, so anytime soon it could happen. So I would encourage you to check out the APA and TMR websites for further information. And in the end, we started with the pavement thickness reduction. In the end, this is what we would like to see here in Queensland and Australia too. This is a cutout from the draft supplementary document for the pavement design. You can see for a certain traffic loading, 200 mm DG20 dense graded asphalt would be replaced or could be replaced with 190 mm EME. What did I say? 250?
200.
Oh, sorry, that's 250. 250 dense graded. That's equivalent with a 190 mm EME2. And certainly, it's not only the benefit in pavement thickness reduction, but in terms of constructability and timing, you could put down 2 layers of EME instead of 3 layers of DG asphalt. And that's basically about the trials, Cathy. Before we wrap up, do we have any immediate questions?
Thank you, Laszlo. We have many immediate questions. I'm doing my best to try and answer them here. We have a couple of comments I'll start with, and Warren has told us there's an EME trial starting in the Gold Coast next week.
Okay, that's good to know.
Thanks, Warren.
Thanks for that. We will certainly follow up.
Sorry, Sunshine Coast. I got that wrong. Sunshine Coast. Thanks, Warren. The other questions are around, this one's addressed to you, Eric. You may be aware of the recent trials in Durban, SA, that have incorporated RAP in the EME design. It was in the latest SABITA newsletter. Any comments?
Yes, I saw that, and that is very encouraging. I actually think that our original design that went down in Durban had wrap in as well, pretty sure. And also we did some trials with warm mix asphalt back then, too. Um, uh, so yeah, it's really encouraging to see how it's taken off in South Africa. I think they had some problems with the availability of the binder. I'm also pleased to say that in Australia we now have 3 producers, if I'm not mistaken. So 3 bitumen producers that can supply the binders within the specification. So that's great in terms of the availability. I don't think that will cover the entire country yet, but we're getting there. Yeah. So it's great to have this feedback from South Africa.
Thank you, Eric. Now we have a few questions all on the topic of how long the French have been doing this for. So Ryan's asking, are there any French monitoring projects to demonstrate EME durability performance 10, 20 years? And who else is also asking? Tay's also asking about how old these EME pavements are, how do they meet the design life well, and how long has France been using them?
Okay, we covered that pretty much in the report. If you would like to read more about that, you can go back. Just a quick summary, it has been used for 30 years, and I think it's quite a good validation time. And to date, there has been no adverse effect reported. So EME2 works very well. It's quite a favorite mix in France, to our best knowledge. And we would like to see more field trials, or rather big-scale operations with EME here in Australia to see how it picks up. But because we tested the control mixes in the laboratory too, we do have the confidence that the EME performs exceptionally compared to the DJ20 mix. So can't really see big risk with the application, but certainly we need to get confidence through field trials.
Thank you, Laszlo. I think we one more question about the bonding quality of EME2 with adjacent layer.
Okay.
Well, EME has got a very high binder content compared to normal asphalt. So I'm led to believe that normally you don't even use a tech coat on top of EME if you come with the next layer immediately after if you would place the surfacing. So it's definitely not worse than normal asphalt. It might be slightly better. It all depends on the mix that is being placed, because some EMEs get a bit fatty at the top, which is not a problem since it's the base layer, but that increases, of course, the bonding with the next layer. Some of them are a bit drier. That will depend on the situation.
That's right. And just a visual feedback, when we took out cores from the trial here in Brisbane, there was really good bonding between the varying cores and the base layer. But we have to keep it in mind that was a controlled production, so we really kept an eye on the temperatures. If you do production as per normal, that shouldn't be a big problem.
Thank you. This is a good opportunity to remind everyone we will be sending you a copy of the presentation notes as well as a recording of this webinar after it's finished. And we also have the link to the report in the presentation slides. So for all of those more detailed questions, it sounds like everybody wants to know a lot more about it. You can have a read of the report after the webinar today. We might let you carry on for a few more minutes and then we'll take some final questions at the end. Thank you, Eric and Laszlo.
Thanks, Kathy. Okay, so we just have 2 or 3 slides in summary. Basically, all we want to say is that the technology transfer has pretty much been completed, as in we now have confidence in the interim specifications that we have set for mixed design here in Australia, and we can also design pavements using within the Ostrow's framework. We've already shown that in pavement design we can make that reduction in pavement thickness happen. One thing that we need to point out is that careful implementation is needed. Laszlo has alluded to some of the differences between how we design EME and how we design conventional asphalt, and also the differences in the test methods. It's very important that anyone attempting to design an EME mix follows the interim specifications to the letter and don't just assume that the test methods are the same, because they're not.
Because, yeah, that's very important, Eric, pointing out in the background that we had the support from industry, and that was very detailed work, that we don't go with assumptions that two test methods would be equivalent, and this is how we can really revert back that the validated performance in France could be transferred here in Australia if we exactly follow the same pathway. So any short, any cutting in the corner, that would be quite risky for the EME2.
Yes. Yeah, so we have been very careful that we transfer the technology, and that includes the design philosophy, which is strictly performance-based. In a way, we hope that actually EME2 is a vehicle to introduce more performance-based mixed design to Australia. So validation, we went through extensive laboratory testing, and I think we cannot stress enough that these trials are really demonstration trials. This is a proven technology, and we went through a lot of effort to make sure that the technology that we implemented in Australia is equivalent to the technology in France. So there will be more production and demonstration trials. I think that the trial Warren alluded to just a moment ago is a new production trial and a new EME mix in Queensland. So that's great news. More and more mixes become available. There are various asphalt producers who have actually more than one mix in various locations around the country. So it's really being rolled out at the moment. So the current status, we have Australian mixed design requirements, and there is a pavement design framework that we developed for the Department of Transport and Main Roads here in Queensland. So the next step is really for hopefully for other road agencies to jump on board and start rolling this out more widely. And I mean, from the support we've gotten for it, because I think that we cannot emphasize enough the role of the different road agencies, Austroads, and industry in developing this. Has been a big collaborative project, and I think with great outcome. And I hope we're going to do a lot more technologies like this in the future.
Okay, thank you. Now we have, as promised, we've got Laszlo's and Eric's details up on the screen there now. So please don't hesitate to contact them. Their email addresses are there, and the link to the report is also on your screen. Now you'll get a copy of the presentation slides later today or early tomorrow, and it sounds like everyone will go and read the report. We might just take a couple of final questions because we do have 1 minute, and I do apologise to those questions that I haven't been able to get to. It has been a very interested audience. I guess Eric and Laszlo, there's some interest in weak subgrades, and do you plan to trial sections with weak subgrades? And I guess, is this an opportunity if somebody does want to do a trial in their particular area? Do they get in touch with you, or how would they go about getting a trial happen?
Well, I think that, Laszlo, you can answer now, but I think we're very interested in being involved in trials in any circumstances, but really the type of preparation that you need for an EME wouldn't be all that different from your normal deep lift asphalt pavements.
No, that's right. Not very different. In the French pavement composition, you have a much stronger support compared to in full depth asphalt pavements, I mean, than compared to the Australian way. So at the moment, just to make sure that you can compact EME correctly in the field, the first layer, there are certain requirements for the subgrade and subbase layers that you have a good support for the EME2. Just remember, this is a stiff layer, so you don't really want to put that into the mud because you can't really get the performance out of it.
Yeah, so there's two things that I would like to point out there, though. It's that, well, like Les correctly said, in France they have a much stronger support for all their asphalt pavements, not just EME. And I think what EME is, from the experience we've seen so far, is as compactable as normal asphalt. So I think we'll be pushing the envelope when it comes to weaker supports and subgrades as we go in the future. Currently, we're a bit wary not to break the method or EME before or have unsuccessful trials. I think that's the main thing. But I personally do not see massive issues in using EME just like you would use any other asphalt base material.
That's correct.
Fantastic, thank you. Unfortunately, we have now run out of time, so I do apologise to everyone who has sent through the questions. I hope that the publication gives you a little bit more detail, and I do thank you so much for your participation. Thank you very much to Dr. Laszlo and Dr. Eric. It's very exciting, very early days for EME2 in Australia. So, and it sounds like you have an audience here who wants to get involved. So thank you so much for your time in presenting today, and thanks to all of our audience for joining in on our EME2 webinar. We'll see you next time.